All right, so today we are going to add, subtract, and multiply polynomials. Again, this is something you did in Algebra 1. So most of this will be review. There is one new special pattern that you will not have seen before that we're going to go over. But then the rest of this hopefully is review for you. So adding and subtracting polynomials. There you can use a vertical or horizontal format, whichever you prefer. The main thing you have to be really careful of is when you're doing subtraction, you want to make sure that you distribute the negative. Don't forget that. Don't subtract just the first term, but subtract all of them. Is that enough emphasis for you to get it? All right. So, and then after you've distributed your negative, if it's a subtraction problem, all you have to do is combine your like terms. So, for example, example 1, I've got 2x cubed minus 5x squared plus 3x minus 9. And x cubed plus 6x squared plus 11. So first I'm going to show it to you in a vertical format. Again, you can choose whichever format you prefer, and it's up to you. So when you're doing the vertical format, you want to line up your like terms. So I'll write the first one. We've got 2x cubed minus 5x squared plus 3x minus 9. And then for the next one, I've got x cubed plus 6x squared plus 11. So I'm going to put the 11 under the 9. I don't have an x term in my second one, do I? So I don't worry about it. I just leave a space there. Okay? And then you just add going down. So 2x cubed plus 1x cubed, that's 3x cubed. Negative 5 plus 6, I get 1x squared. And then plus 3x plus 2. So that's doing it with vertical format. And then if I want to do it horizontal, that's probably the way you're more used to seeing it. It just means you're taking 3y cubed minus 2, y squared minus 7y, and you're adding it to negative 4y squared plus 2y minus 5. So if I'm doing it horizontally, I'm just looking for like terms. So that's my only y cubed, right? So we get 3y cubed. And then if I look at y squared, I've got a negative 2y squared and a negative 4y squared. So that's a total of negative 6y squared. And I have a negative 7y and a plus 2y. So that is minus 5y. And then we just have the minus 5 on the end. So those are pretty straightforward. You guys remember doing those before, right? Okay. All right, so subtraction are the ones you have to be a little bit more careful on. And again, I'm going to show you both vertical and horizontal. It's up to you, whichever one you prefer. Now, you have to be careful. If they actually give the problem to you like this, as opposed to just writing it as a subtraction problem, read it carefully. I'm subtracting 3x cubed plus 2x squared minus x plus 7 from 8x cubed minus x squared minus 5x plus 1. So which one of those is on top? The second one. So that's what you want to be careful of. The thing being subtracted is the first one. So, so I'm taking the second one, 8x cubed minus x squared minus 5x plus 1, and I'm subtracting 3x cubed plus 2x squared minus x plus 7. So what I recommend you do is, before you do anything, we'll make a fancy arrow there. Before you do anything, distribute that negative. So the top one stays the same, 8x cubed minus x squared minus 5x plus 1. But then I get negative 3x cubed minus 2x squared plus x minus 7. And then just add them together. So 8 minus 3, I have 5x cubed. Negative 1 and negative 2, I get minus 3x squared. negative 1 and negative 5 and positive 1, I get minus 4x, and then minus 6. So distribute the negative. That's the most important thing you got to remember on these. All right. And then and then you add, yeah, because subtracting is the same as adding a negative. So, yeah, if you distribute your negative, then all you have to do is add, and you don't have to think about whether it's positive, negative, or whatever. You just add them up. All right, and then the horizontal format, that's probably the way you're used to doing it. It seems like it's the way most of you do it. Is now, again, I'm subtracting the 5z squared minus z plus 3. That's the one being subtracted from 4z squared plus 9z minus 12. So I assume, again, you treat it kind of like it's a negative 1 out in front. You have to distribute the negative to every single thing inside. So the first ones, I'm not doing anything to them because nothing's happening to them. And then we have minus 5z squared plus z minus 3. And then again, it's just a matter of combining your like terms. So I've got a 4z squared and a minus 5z squared. So that's negative z squared. And I have plus 9z plus z, so that's plus 10z. And then finally minus 12 minus 3, I get minus 15. And so the final answer is negative z squared plus 10z minus 15. Okay? So here's one for you guys to do on your whiteboards. Or if you want to do it in your notes, you can just write your answer on your whiteboards, whatever you prefer. Alright, looks like everybody's getting the same thing. You guys got 6t squared minus 7t minus 6. Any questions on that? Alright, here's a subtraction one. So what do you have to remember to do? Distribute the negative, that's right. Okay, go ahead and do this one. Okay, so again, I think everybody pretty much got there. We got 8d cubed plus 13d squared plus 8d plus 1. Questions? No? Okay. All right, next thing we're going to talk about is multiplying polynomials. So you can do this in a vertical format if you want. And then I'm also going to show you how you can do it in a box. And then we'll do one the horizontal way. So I don't know whether you'll choose to use this method, but I just want to show you it can be done this way. I can multiply negative 2y squared plus 3y minus 6 times y minus 2. And we can actually write it just like a regular multiplication problem. So negative 2 times negative 6, I get a positive 12. And negative 2 times negative 3y, I get minus 6y. And negative 2 times negative 2y squared, I get a plus 4y squared. And then I do the same thing with the y. I skip this one because the y times negative 6, I put my negative 6y under the other negative 6y. And then y times 3y gives me 3y squared. And then y times negative 2y gives me negative 2y cubed. I didn't quite leave myself enough room there, did I? All right, and then you just add going down. So negative 2y cubed plus 7y squared minus 12y plus 12. And that would be your answer. Okay. The other way you can do it is with a box. And so some people like using the box to multiply just to keep themselves organized. It's up to you. Again, I don't mind which way you choose to do it. It's whatever works best for you. So I would put my y and my minus 2 on this side, and then my minus 2y squared plus 3y minus 6 across the top. And then you just multiply y times negative 2y squared, and I get the negative 2y cubed. Y times 3y, I get 3y squared. Y times negative 6, I get minus 6y. And then negative 2 times negative 2y squared, I get positive 4y squared. Negative 2 times 3y, I get negative 6y. Negative 2 times negative 6, I get positive 12. And then when you look diagonally, there's your like terms right there. So this is another way that you can organize it. You can see I end up with the same answer, negative 2y cubed plus 7y squared minus 12y plus 12. Okay? Any questions on how I did that? No? Okay. And then, is there a question? All right, so yeah, you guys are probably used to just seeing it horizontal using the distributive property. And if you want to continue doing it that way, I'm totally cool with that. Whatever works for you. It's just a matter of not losing track of where you are and leave out any of them. So the advantage to the box is it keeps you from missing terms. But if you're good at doing it this way, there's nothing wrong with that. So I'm going to distribute the x to everything within the parentheses. So x times 3x squared gives me 3x cubed. X times negative 2x gives me minus 2x squared. And then x times 4 gives me a positive 4x. And then I do everything, the 3 times everything within there. So 3 times 3x squared gives me 9x squared. 3 times negative 2x gives me a minus 6x. And 3 times 4 gives me a positive 12. So when I simplify it and combine my like terms, there's only the 3x cubed. Then I have negative 2x squared plus 9x squared, so that's plus 7x squared. And then 4x minus 6x, I get minus 2x, and then plus 12. So again, whichever format you prefer, you can do that, okay? The other thing you might see tonight as you do your homework is multiplying together 3 binomials. But again, it's just the distributive property. So we've got x minus 5 times x plus 1 times x plus 3. So what you want to do is you'll go ahead and distribute your first two and get an answer. So why don't you guys figure out what that is when you multiply those first two together. So quiet. Okay, so what did we get when we multiplied those? X squared minus 4x minus 5. Okay, and that still has to be multiplied times x plus 3. So now I'll let you guys finish it off. Go ahead and multiply those two together and see what you get. All right, so what I'm seeing is some people are trying to just combine the like terms and do it all in their head in one step. So please don't do that. Go ahead and multiply them out. So x times x squared gives me x cubed. X times negative 4x gives me minus 4x squared. X times negative 5 gives me minus 5x. And then 3 times x squared gives me a positive 3x squared. 3 times negative 4x gives me minus 12x. And 3 times negative 5 gives me minus 15. So I have x cubed. And then I've got a negative 4x squared and a plus 3x squared. That's minus x squared. Negative 5x, negative 12x is minus 17x. And then minus 15. Okay? Those of you that didn't get that, did you figure out where you went wrong? Yeah. Okay. All right. All right, then the last thing I need to tell you guys about are special product patterns. 2 of these you've seen before. You've done sum and difference before, and you have done the square of a binomial before. There is a chart on page 347 if you want to refer to it. It gives you examples of each. I'm just going to write the general formula for these. So the sum and difference pattern, that's when we had a plus b times a minus b, and our answer was always the difference of squares, a squared minus b squared. And the square of a binomial, a plus b squared, when we square it, it always comes out to a squared plus 2ab plus b squared. And if it's a minus b squared, we get a squared minus 2ab plus b squared. Okay, those are patterns that you guys have seen before. We've already even been using them this year, right? Just going the other way when we were factoring. All right, so this one is new though, the cube of a binomial. So the cube of a binomial, if I have a plus b cubed, you end up getting a cubed plus 3a squared b plus 3ab squared plus b cubed. And if it's minus, it's almost exactly the same, just your minus signs alternate. It goes minus plus minus. So we get a cubed minus 3a squared b plus 3ab squared minus b cubed. Okay? Now, if you have a hard time memorizing this, what can you do? How could you figure it out if you don't remember the pattern? Just multiply it out. Okay? So it's not the end of the world if you can't remember the pattern. You just multiply. If it was x plus 3 cubed, you would just do x plus 3 times x plus 3 times x plus 3. Okay? The pattern just saves you some time. All right? So, so some samples of each one. The first one, this is a sum and difference pattern, right? And so I'm just going to take the 3t, I'm going to square it, minus the 4, which is squared. So instead of having to distribute, if you know the pattern, you can just use the pattern as a shortcut, a squared minus b squared. Well, a is 3t in this case, so 9t squared. And then the b was 4, so minus 16. So the patterns just save you some time. But if you can't remember the pattern, it'll still work to just use the distributive property. All right, so the next one, we've got the square of a binomial. So it's a squared, so that's my 8x squared, minus 2ab plus b squared. So I get 64x squared minus 2 times 8 is 16 times 3 is 48. So minus 48x, and then plus 9. And then using the last pattern, I have a cubed, so that's pq cubed, plus 3a squared b plus 3ab squared plus b cubed. So pq cubed is just p cubed q cubed plus 3 times 5 gives me 15 p squared q squared plus 5 squared is 25 times 3 is 75 pq, and then plus 125. So I'm going to give you a couple of practice ones. Actually, we just have time for one more. So I'm going to have you guys practice one of the cubed ones since that's a new one for you guys. So don't worry about that one. I'm going to have you do this one. Okay, so go ahead and try using the pattern to figure out the answer for xy minus 4 cubed. All right, so I can tell some of you are getting confused about the signs because of the general one with the minus sign. If you don't want to think about it at all, you can always use the, whoops, wrong color. You can always use a squared plus 3a squared b plus 3ab squared plus b cubed, and just have the whole thing, the negative 4, be your b, and then your signs will work out. The way that that pattern is written with the a minus b, they were just assuming b was a positive 4. So that's where you guys were getting off. So you should end up with x cubed y cubed minus 12x squared y squared plus 48xy minus 64. Okay? So I think most of you were getting that. It was just the signs were confusing you a little bit. So, all right. That's it for today.